Okay, hello. Are you happy to see you again? Another week. Today is our last day. Um, I want to make a review about what is your feelings about this subject. How do you feel? Um, what about your expectations about at the beginning of the subject? What do you think? How do you feel is more or less cover this subject or expectations or not? What do you think? Today is an open day to talk about your projects, and for me, it's very important to talk about your feelings. What do you think? Who can share that? Elsa and Liva, probably. What do you think?
Uh, I think it's quite good at the end. I'm taking my first steps into programming world, but I have a question about what do you expect from this practical part? Only the Word document where we describe everything.
Um, for me, the for me, the goal of my expectation about this subject is you have people that never programmed before. For me, that is enough. I think last exercise we did, like the Sudoku, I think you understood more or less what is the how this program works. It's a complex exercise, this Sudoku. You just so I showed you this as implementation in 99 Prolog problems with 236 lines of code, very complex code. We resolve using this Markus Triska implementation in only a few lines. Very efficient, smart implementation. And I think for you will be interesting in the future if you will be involved in any type of problem. You can remember, okay, I remember my lessons in Spain with this type of programming language. Probably I can resolve some problem. For me, that will be enough. If you remember what you did here, or probably that can help you in the future to help your students or in your company, or probably if you be involved in any project related to I don't know, whatever field, and will be interesting. Okay, I remember I resolved a Sudoku, a puzzle problem, or some problem with a list. Um, I know how can do a little program to resolve that. That will be perfect for me. That is enough. That is enough to have this new capability for you. Is I know it's hard. Start from zero to program some complex problems as we did. So for me, it's enough. In your projects, it's like try to resolve one exercise more or less by yourself. Um, I can help you, of course. If you have any question, I can try to resolve your questions. But for me, will be enough. Try to do one exercise by yourself and think about everything we learn about induction and this last part of constraint logic programming. So
So
I'm
we can, sorry,
mhm. Yes,
we
yes.
can then submit just like one paper, for example, in Word where we describe how we resolve this. Yes.
Yeah, it will be enough. Yeah, that will be
Okay.
enough. I know you was in the classroom. You have the videos. If you have any question, you can see these videos again. I know it's complicated to only 4 months to integrate this capability of programming. But this is only a start for you. If you want, you can go look for more information about that. You have the Markus Triska webpage. It's a super place where you can find many type of exercise. And we resolve one of the exercise he did. He used frequently the map list, predicate, and certain similar things, and constraint logic programming. And we see how this library works. It's similar to what we did before. So I think you can try to search by yourself after this start point. It will be that I think that will be a good start point for you if in the future you want to discover more. You have this link about the power of Prolog. We have the opportunity, if you want, because I sent an email to Markus Triska. I was talking with him last year, and I sent the link for the video we created last day. He told me, give me thanks for use the material he create, and we have the opportunity to have a video conference with him, and probably you can make questions if you want. I don't know if you will find interesting. And just today, a professor in my area here in my department, he was talking about a new plan in European Union about reinforce the idea of the use of artificial intelligence in Europe in general, in many different fields, and they create an white book of artificial intelligence, and it's related exactly with we did this semester. We are now you know, or you have this start point, or this is basic knowledge about artificial intelligence. The technique we use to resolve the Sudoku as pure artificial intelligence techniques to resolve things. The puzzle are pure artificial intelligence. Today, if you want, I can show you more examples about that. You have the knowledge to start your own way, your own path. If you want to go more deep in this field, you have the knowledge to start to search more information. And that is another interesting thing. Now I remember two girls some years ago who did this subject, who wrote me after one year after this lesson, and they told me they are using some of the exercise we did here in this subject to a final project in the university. So I don't know. It depends of your interest in the future. Will be, for me, that is enough. What you learned at this point, for me, is enough. Now this project is like a final work. Okay, more questions? Or question or things you want to share, not only question. I want to know what is your feeling about this subject. How do you feel? It is, or it's too complicated, or will be enough, or something like that. Natalia, do you want to share your feelings?
For me, it was very okay. but I think it was hard because it was new for me.
Yeah.
But it's okay. Now I did all my final project, and I think I did it correctly, but we will see.
Okay. I know when you are a student, one of the most important point is to pass the subject, no? But for me, it's very important don't lose the focus on in learn new things, not only pass the subject, because sometimes you can pass on one subject and you don't learn nothing. For me, that don't make sense. If you pass the subject and you don't have nothing inside you, it don't make sense for me. So I prefer, for me, it will be good if I give you your 5 at the beginning. Okay, you pass this subject, and now forget about the stress in pass the subject. Put the focus in learn. Only try to learn whatever. Everyone, this is a very special classroom because we have from very different previous knowledge. There are people who never programmed before, and it's we are together, people from different fields, economics, no, and education, many other fields, and all of you try to understand that type of programming. So it's so nice. Okay, Laura.
Yes, I feel actually pretty good because at the beginning I was really confused with Prolog and I didn't really get it. So right now I think I start to understand it. So I think the project will be fine.
Okay, perfect, nice, super. And you think you if you understood the last exercise, probably you can go to Markus Triska webpage, and try to discover new exercises. Since he have a lot of exercises. Probably you can try to, let's go to do today. Let's go to take a review of the most interesting exercise he has in the web page, and you can try if you want in the future take a look and try to discover or try to do by yourself. For me, in the future, I want to resolve more exercise in the way that Markus Triska do. So probably in the future, if you want, next year, or you can go to my YouTube channel and probably you can find more exercises in the same level. Very simple. I try to explain with very simple way. I don't know. Probably you can back again if you want and look for more information. Perfect. Alexander.
So at the beginning, I wasn't too sure about Prolog because I thought because of the simpleness and that you could just like implement the logic rules. I thought it was pretty limited, but after seeing the example with the Sudoku, I'm really surprised
Yeah.
how difficult problems you can actually solve with that.
So yeah, totally agree with you. Yeah, for me too. For me, it's because before now this constraint restriction or constrained logic programming, solve this exercise is really complicated. But this new concept for me is like a revolutionary concept in Prolog. So not only for you, this is nice because resolve only these few lines is something like incredible, no? Many things you can do in this extremely simple way. Nice. I'm happy. I agree with you with the idea to host in what simple, extremely simple way you can resolve this so complex problem. I want to show you a 36 by 36 Sudoku resolve. It's go really fast. It's a huge Sudoku. It's like I don't know. You need a big paper to write this Sudoku. It's really it's for me a surprise how fast this method or library resolve this problem. So surprising for me too. Something new. I discovered this way of programming last year, and today is the second year I'm trying to go deep in this type of programming. So I'm going to show you today the program to planify classroom timetable. I'm going to do now some example. It's super interesting, this exercise. Adriana Sobieska, happy to see you.
Yeah, it's so for me it was a great experience because I've never programmed before, but I've always had problems with IT classes, to be honest, because it's not really my thing. But you explained it really well, so I understood and had fun in your classes.
Okay, nice. Happy to, yeah. I try. Sometimes it's difficult. I know we started more people. I don't know. Today, 1, 2, 3, 4, 5, 6, 7. At the beginning, we started, I don't know, 5 more or something like that. I don't know if probably someone that follow all the lesson, but he or she can't do this lesson online today. But I don't know how many people will finish. But it's we have more people in this English version of knowledge representation, more people than in the Spanish usual lessons. So I'm so happy for that, for all of you to be here at the end of this lesson. Luca, are you there?
Yes, I haven't much to say about the course because I already programmed in the past. Prolog is completely different from the typical programming language, but with I don't know, maybe a year of practice, a couple of years, it can be owned, let's say.
Nice. Yeah. I understand you. It's the same that happened with my Spanish student. He knows how to have previous knowledge of programming, and it's hard for them to learn this new. Is for them, it's like have a double work. It's like stop the brain when try to resolve in a typical way.
Yeah.
I have to say the brain, okay, stop. It's okay. The other way works when you try to program in, I don't know, Java or Python or another programming language. But here it's very important to recognize the way is totally different. It's nothing, it's like if you know, for example, English and French or of Latin, a group of Portuguese or Espanol, and you try to learn Japanese or Chinese, it's totally different. It's like to say, okay, this is totally different way. There are pictograms, and nothing bad happen in your brain. I think if you have the two models in your brain, you open your brain more. You are opening your brain. If you know how to program in imperative programming, it's perfect. I usually this is my more common way to program. Right now it's changing, like more using declarative programming, but you can have the two ideas at the same time. Your brain is like you surf and make your skateboard or drive a bicycle or drive a car. You're opening your brain to new ways to do things. I think that is more one of the most important things to have your brain open to really new things, not only similar things like drive a car and change to drive a van, very similar things. No, to do really different things like surf, for example. It's totally different. Your body have to train many new things, and that is what happened with Prolog, something totally new. So I know for you it's a double effort. I know that it's a double effort.
I also wanted to ask something. I sent you an email with the exercises that I wanted to do for my project.
Yeah.
I was thinking about doing number 90 and 91.
The 99 problems. 90.
Yeah, but I don't know. Maybe if it's too much doing 2 of them, maybe I should focus only on the first.
Yeah. Try to. I don't know. I don't remember now. What is the exercise?
90 is the 8 queens problem. 91 the knights problem.
Yeah, I prefer, if you want, to, because Markus Triska have also this this problem resolved, the knight queens problem.
So
Markus Triska.
Yeah, I heard it.
He resolved this exercise using the CLP library. I think will be more interesting for you. Try to understand what is the method of Markus to resolve that. Will be more simple, are more fast probably. Probably you have to learn some new things probably.
Yeah.
Will be good if you try to take a look to the code of Markus to 9 queens. That will be a good exercise for you, I think.
Okay.
Okay, try to resolve in the Markus Triska way.
Okay.
Take a look. If we can take now, if you want, take a look to this code to see how many new things you have. Okay, let's go to take a look now if you want. After this round of sharing your feelings. Okay, thank you, Luca. Natalia Sawatka, are you there?
Yes.
Do you want to share your feelings?
Yeah, so for me, at the beginning I was really afraid of that because actually I'm not good in Excel, so how can I do this?
Okay, nice.
I'm okay, but we will see after my practical part because I want to start the second part of our project today. So I hope I will be okay with that, to do it totally by myself.
Okay. Try to do, and if you have any question, I'd say for all of you, we can try to find a day to have an online session if you want, like another session with Zoom to resolve your questions. If you need from today until the last day, 21, I think, 21 of June, for the last day to send your exercises. So you have time. You can ask if you need for this online session. Okay. Perfect. I'm so happy you started with this phrase. Normal, I think. Start in this way, something totally new for you, but you are here at the end. He's so happy for that, to make this effort, no, to try to open your brain to something new. Sometimes when I think people in general, when you are in front of some challenger of this type, many people say, okay, stop, goodbye, I have to go to do other things, but you are here. So that is so interesting. And this professor that was talking today, this very interesting speech, I will try to upload to YouTube and probably make the translation to English, because he did many interesting information about what is the future in Europe about technology. And he said that artificial intelligence will be one of the main aspects in all fields. Like they told, like for example, in healthcare, in agriculture, or business administration in general, you can apply this idea to many fields. So, and Europe, because now they talk about the situation now in artificial intelligence area in the world, and Chinese and American people, American government and companies are ahead, are they said around 70% of the new patents in the area of artificial intelligence are from United States or China. So Europe is starting to be in the back side of this competition for the knowledge or the research in artificial intelligence. And now Europe want to make a big effort in economy for enterprise to develop or give money to companies to develop projects in artificial intelligence, in any field, any, doesn't matter about what is your field, probably you will be involved in the future in some aspect in artificial intelligence. And this subject will be for you a good start to search by yourself. Okay, more questions? Satimo? I'm so happy. I'm so happy with this group this year. So very happy with you with making this effort. If you want, now I'm gonna share the screen and let's go to take a look. I'm gonna show you some things about these exercises in the Markus Triska page. Probably you can take a look. One of the most interesting exercises I see this day was this planify, or this program to planify the timetable in the school. I want to show you how this works, and take a look a little. Take a look to the code of this program. It's here. Here. This is a good starting point. Here at the end, you have also many exercises like Connect 4, and the Queens is here. This is the exercise that Luca was talking about, and the Queen's problem, and some Sudoku with solid state. This is the exercise of this timetable engine. Let's go to take a look to this exercise. Here you have an explanation. You have also a video where Markus explained how this program works. And he created a demo, online demo for this program. Let's go to take a look to this. For me, this is very surprising a way to resolve. This is a very complex. It's a very complex task that in many places have to resolve. Universities, schools, or private organization to have to schedule many different tasks. Look at this. He created three different examples. The first one is the most simple exercise. Here he created, this is a Prolog fact is like to say you have 35 slots per week. That means you have seven slots per days, have 5 days from Monday to Friday, 5 days multiplied by 7 is that in total 35 slots per week. And a slot will be a block, will be 1 hour, or depends, 2 hours or half an hour. It depends on your needs. After that, you can make the sense to this slot or give the size, the time size for this slot. And the other information that is needed to create this timetable is this it's a group of facts where you say here, what is the class? Think about one school. When you have one class, you have the subject this class need, the teacher that are going to teach this class, and how many times a week is needed, how many slots are needed in a week. It depends of the subject, probably need 4 times a week or 2 times a week, depends. And how they create give the information to Prolog in this way, with many lines of this type. They say, okay, we have one classroom, 1A, and this is the abbreviature for the name of the subject, wherever. Okay, here mathematics, English, history, geography, biology, whatever. And this is the name, is a abbreviature for the name of the teacher. Let's say will be the initial for this initial letter for the name of this person. Say Professor SJK1, Math 1 is the mathematical teacher number 1. If you have more than one professor of mathematics, and here you put this name to identify the professor, all these names. And here last one is the times a week are needed for this subject. With all the information, all that information, here you have 3 different examples. This is the most simple one. I have another one a little bit more complex. I have two classroom. Here, this is the information for the first one. Here, say I want to have a free slot at the beginning of the week. Mondays, the first block are free and the second block are free too. You can define this type of relationship of information. I want to say, okay, I want to have this free, or for example, you can say this professor are not going to give lessons at the first block or line or first slot in the week or whatever. You can define new restriction if you want for your problem. After that, you have to give the sense to this restriction. No? But when you understand what is the mechanic of this to resolve this problem, it's very easy to define new restrictions for your problem. So here have more another one, classroom, and the last one, the example number 3. This is this link is a web server that in the back side of the web server you have Prolog. That is possible to do. You can create a web page. You can use this web page in your mobile phone if you want. It's possible to create a Prolog program that has an web interface. You can access to your program using this Prolog web server. That is what Markus did here. You can find more information if you want about that in the Markus page, but it's possible to do. This third example that is more complex are more classroom, more professor, more restrictions. Here 1, 2, 3 classroom, 4, 5, 6, 7, 8, 9, and 10, 10, 10, 11, 12, 13, 14, 15, 16, 16 classroom. Here you have, in a very simple way, the information for probably an institute or a college or whatever, with 16 different classrooms, with many professors, and each subject had different requirement, like the name of a slot per week. And we give all the information. For example, here are a new relationship that say, okay, this professor have a free day, the day for Thursday are free. This professor can have any lesson this day of the week. And you can create more restrictions in this way. Like, for example, some professor only can give lessons in the morning, not in the evening. It's very easy to create new relationship if you understand this code. It's very easy to create new restrictions. Okay, let's go to see what happened. After that, all that information for 16 classroom, we're going to give that to Prolog and see what happened, given this button go. Look at that, take a look to that. Need only to planify, I don't know, that will be, for example, a semester or probably a full year, I don't know. Only less than 1 second to planify that. Think about if you have to resolve that manually by yourself, it will be really, really hard problem. I did because some 2 years ago, I was the secretary in my department, and one of my tasks was planify the timetable for all the classroom in my department of informatics lessons. I have to planify to make all one timetable like this for any lesson, any classroom, and for any professor. Look at this. Look at this result. Here we have a result that follow or cover all the restrictions we give to Prolog. For example, we say the first slot, 2 slots in the morning are free. Here you have free slot here in the morning. Probably you need here to do some, I don't know, whatever task here. These 2 slots are free. And here we have, for example, the 1A classroom, we say that have 4 mathematics lessons. We have here. And they cover the restriction also with the professor. The professor, this professor that Math 1, if are in different classroom, the program take this restriction of the time. It's not possible to have the same professor at the same time in two different classrooms. So all the restrictions will create this timetable covers. Look at this. First one, here you have the 16 classroom with covering all the restrictions we give to Prolog. Something like magic, how you can get all that in only less than 1 second. All the timetable for all the lessons, and at the same time, we have the teacher's schedule. For each teacher, we have what is the schedule. The professor, the ANG1, this is the timetable for this professor. And the same for all the professor with no, I don't know the word in English, solapamiento, don't have any conflict in the time. Prolog resolve all possible conflict that one professor cannot be teaching in two places at the same time. So there are many restrictions at the same time with professor, classroom, and here we have the result. What do you think about that? For me, something like magic things. How you can resolve this so complex problem in this so easy way. What do you think about that? Laura, tell me, what do you think about that?
Yeah, it's pretty cool. I mean, you don't have to calculate it by yourself. That's pretty cool.
Really hard to. I did by myself manually, something similar. It need a lot of time, and probably
Yes.
And probably the result, if you try to do by yourself, you need more classroom because Prolog will try to find a very good option, try to put in very few classroom. Probably I can do more or less the same, but probably at the end I need more classroom. At the end,
Yes.
it's a question of resources at the end of money. If you don't do a good planification or at the end you need more extra classroom probably to do more easy, more resources, no? So that for me is like something like magic to have all the timetable for teachers, all the timetable for each classroom. So incredible. Many professors, many teachers, many classrooms, and you have all the restrictions covered by this timetable. For me, it's not something like, oof. It's very, I don't know how to say, super interesting and complicated task. I don't, it's not an easy task. Probably this is your first approach for almost all of you to programming language, but this is not an easy task for an expert in programming. If don't use Prolog, will be a very hard problem to resolve for an expert. Not only for you, for one expert in computer programming, try to resolve this problem is a very hard task. But using Prolog, I'm gonna show you the code. It's not an easy code, it's more complex, but you don't need it's good to see what's the code. It's here in this GitHub link. And you have two files. The requirement is like all these facts we see in this example, and this is the code of the program, of this program. Let's go to take a fast look. It's like, okay, 200 in total lines of code, total of, including this example here, less than 300 lines of code. Is think about many computers programs have several thousand of lines. So this is not too much. Probably you can understand, if you take a look here, if you understand the philosophy of this program, probably you can understand more or less this exercise. This is not easy, it's not easy, but probably for you, you can try to understand things here, what's happening. Here, for example, are new things for you, like set off, that give all the possible solution in a list, something new. We saw this map list, predicate, and here is the what way to represent using this constraint, arithmetic constraint, but really don't have so complicated things. Like probably you have to some time to take a look. Yeah, probably here you can find recursive predicates. Here, this is a recursive predicate. You have a empty list, and here is like induction. Here he used here induction. But I think for you, with some days probably taking a look to this code and some help probably, but in I don't know, probably in 1 or 2 weeks, more or less, with not full time, but giving 1 or 2 hours a day, you can understand this code. And after that, probably you can resolve this super complex exercise. And the most important thing is not only understand that this code, most important thing is if you need new restrictions, you can create this restriction for you, because probably this program, it doesn't cover all your needs. And it's very important, if you understand how this code works, can add your own restrictions. Because at the end you want to resolve your own problem, not this general problem. Probably for you, you can say, okay, this teacher only can teach in the evening, not in the morning, or this teacher only have 3 days on Monday and Tuesday. All these things you can implement if you understand and at the end you can create the program or adapt the program to resolve your own needs. And probably you only have to include 2 or 3 new predicates. And it's not too complicated. You don't need to create all this code from the beginning. In computer science, it's usual to reuse code. You have one code, you can understand this code and try to adapt to create new predicates or new functions to adapt to your needs. It's that Google do every time. They take Linux and they adapt to resolve their needs. So in computer science, something very usual to take one code and modify to resolve your problems. And what you need is not to create from zero, is to understand how this code works and have the capability of the knowledge to modify or include new options to cover your requirements. Okay. Any question about that?
One question I have about the code. So you said so we could manipulate the knowledge, so the problem would fit to our problem.
Yeah.
But if it's not solvable, for example, we have the same slots of the day, but just for the experiment now, every teacher could just teach in the evening, so we don't have enough slots. What then the code would just say false, or would it say, hey?
Yeah, probably you will need more. If you put very high restrictions, probably you can realize that it's not possible to planify with this hard restriction. But you will need, or will happen two things, or you need more classrooms if you only can teach in the evening, or you can need, or you will need more professors in other hours of the day. It depends, but that can help you. Probably you say, okay, I have this restriction, and say it's not possible. That's good for you. It's a very important information for you. It's not possible to make a planification, a planning with this hard restriction. And you can play, okay, what happens if I put a new professor in the morning? This enough, or I need two more? Or that's where you can play to planify with these different options. Before contract a new professor, you say, is enough or not with these restrictions? So you can play with many different options before give and obtain a solution. So good question, Alexander. So yeah, it's very interesting. You can play with this variable to see if it is possible or not. And Prolog are going to tell you if it's not possible. Prolog are going to tell you it's not possible to do that. Well, that is false. And now you have to think about modify the restrictions. Okay. Perfect. More question about this? For me, that is pure magic. In only less than 300 lines, resolve this problem, this so complex problem. For me, it's like poof, top level of, and that is pure artificial intelligence problem. And this smart way to resolve, including the output, not only, I don't know, the server probably have more lines, the web server probably have more lines, because this code gives you the result in a text, not in a HTML format. But it's not very complicated to transform this output to create and generate a web page. You need an extra knowledge about how to code the internal code of a web page, but it's not too complicated to do that. Okay, nice. Super magic exercise. I love that. I hope now, for me at this moment, I don't understand every aspect of this code. I need time to, probably I want to ask to Markus some questions about what we did. But probably I don't know, in 1 week for me, or I don't know how many hours, probably, I don't know, 10 or 15 hours more or less, I can understand this code more or less. It depends, probably less, or it depends, no? And after that, you can resolve probably a super complex problem in normal life, in a company or in a school. I think your classmate or will be very happy if you can give a solution in this way. They can be super happy if you can give a solution for this super complex problem. Okay, nice. Or other option that you have, if you know it's possible to resolve this problem in this way, you don't need to do it by yourself. You can go to a Prolog expert and say, okay, I have this problem. I know that it's possible to resolve that in this way. How much I have to pay you to give me this modification? But you don't need to do it by yourself. But you can go, if you know that it's possible to do, but you can go to a Prolog expert and say, okay, I know one expert will need around 15 hours to resolve that. Can you resolve that for me? I'll say, okay, I can do it for you, and you have to pay $10,000. You say, oh, it's too much. I know you don't need all this time to resolve that, no? But that it will be very interesting to evaluate for you what will be more or less the price to resolve this problem if you have this code. An expert, probably an expert can say, okay, I am an expert, I have a very high price for my time, I don't know, 100 or 200 1 hour, whatever price, but you know, the price will be 10 times 10 hours, more or less, for an expert to resolve that. So the price don't have to be higher than $2,000, more or less, more or less. That is a very interesting knowledge too. Not only to do it by yourself, also to try to find a professional to resolve it for you. Okay, let's go to take a look to this N queens that propose Luca, sorry. Look at this. This is the code. Look at this code.
Yes, I already seen it in the past days. I was already working on this code. I didn't know it was from this guy. So
super smart solution. If you take a look, let's go to take a look to the 99 problem solution. 99 Prolog. Let's go to take a look to see the difference. And you can see the power of this logic constraint logic programming. What is the name? 91? No.
90.
90?
Yeah.
Equine problems. Okay, let's go to take a look at this code. Okay. Okay. It's not too big. Probably that will be less efficient, this code, I don't know. But it's not too complicated, not too long. And they have no codes here that I like that. But I think that is more interesting implementation, no? Only this few lines. More clear and smart, probably more efficient too. And here they talk about the Scryer. Probably let's go to take a look to the code. And they need more code because more like because they animate this program to see how the evolution of the solution. But the code is only that. It's only that. That few lines. The other code is for do the animation. You have a video also, no? Do you have a video explanation? Yeah, you have a video here. You can take a look to this code and try to understand how that works, okay? Luca? Okay. What more? Nothing more? Any question? I think today we're going to finish before the lesson today. Another interesting exercise is Connect 4. This is a classic game. Let's go to take a look to the code. Empty board, set piece, It's more long code, probably for the representation too. I don't know. It's needed. This was more. Is it a representation to create a solution? I don't know. Well, you need to take a look to this code. This is it's something that we don't need. We don't see this use of this dot and comma here. That is like this is an or. That happens or the other things happen. We usually do that with two different lines, not only in one clausula or clause. This is we don't use that, but we did in other ways. It's possible to make the transformation. Okay, I need let's go to make a break, 5 minutes, okay? Let's go to back and see some exercises more if you have some questions. Probably today we are going to finish a bit earlier, okay? 5 minutes, stop, okay? See you in 5 minutes. Okay. Any question about this exercise or any questions so far? Luca, what do you think about this exercise? You think it's possible to resolve, to understand that?
I still have to study it for some more days.
Okay.
I don't know.
Perfect. If you decide to change, tell me. But I think
no. I think I will deliver this exercise.
Yeah. Did you have a video here with Markus create a video, an explanation? If you have some question, write me. I have now it's easy to talk with Markus. If we have any question, probably I can ask him. He told me if I have more questions of any exercise, he can help us with that. Okay. Perfect. I don't know what more we can see. Alexander asked about the puzzle problem. I don't know, it was zebra problem, no? Let's go to take a look to this code, to zebra problem. I think it's here. You have to go there to the power of Prolog. And then with chapter 9. And at the end, you have the link to these puzzles here. Puzzles. Here's some puzzles. And we have this zebra puzzle. And this is, you have here the solution. the solution for this exercise, if you want to do, someone want to resolve that or another similar puzzle, the idea here to resolve that is try to code any solution with integer numbers, and at the end represent the problem using these numbers, and the relationship between the elements are created using numbers. For example, here say, okay, we have I don't know if you know this problem, how this, you see that this problem before. Let's go to take a look before at this explanation. They say, okay, set up as to say there are 5 houses, each painted in a unique color. The inhabitants are from different nations, own different pets, drink different beverage, and smoke different brand of cigarette. So they have 5 houses, 5 colors, 5 different nationalities, 5 different pets, 5 different drinks, and 5 different smoke brands. No, this is the idea. Or brand of cigarettes. Okay, and with this initial idea of 5 houses, 5 nationalities, different, they probably start to give you information to try to, it's like a puzzle, because you have initial what's the name? Marco, initial square, and you give information that you have to put in the position. At the end, you have a question that you have to resolve. This is, if you put all the information in this square, on this puzzle, at the end you can resolve the question the problem has asked you. So this is the information the problem gives you. The Englishman lives in a red house. So we have to represent all the information here using this method of integer constraint. This is the idea. Oh, I'm sorry. 1 second. Okay, sorry. Okay, nice. The idea is represent each of these information, of these lines, using the integer representation. So Englishman lives in a red house. Let's go to the code before continuing with the other lines. Okay, how do you represent, how Markus represent this idea of 5 different houses from different nationalities? You represent that with a list of 5 different variables, different colors, 5 different, and inside this variable, with to obtain the solution, the Prolog are going to put a number from 1 to 5, and that represent the house. You have red. Who is the house that is red? I don't know, but Prolog are going to give a number. Will be the number, house number 1 or house number 2 or wherever. The same with the rest. Here we have numbers from 1 to 5. Which house is the England or the Spanish man? I don't know. And Prolog are going to give you the number, the number of this house. This is the names of England, Spain, look at this. This is variables. Variables are start with capital letters, but that are not variable, are constant. It's not a variable, it's a constant. It's a name. Here, drinks, coffee, the same. I don't know this coffee in which house are this person drink. So Prolog are gonna give the number of the house, one number from 1 to 5. A smoke, here are the brands of smokes, but as variable, we need to put the number of the house inside. And animals also, as a variable, I have to put here what is the number of the house. And when I have all this number of the houses, I have the full solution. I will know every information about the house. What is the nationality, what is the drink, what the cigarette, the brand of cigarette that smokes, and the pet. Okay, and say, okay, the variables are from 1 to 5 because there are 5 houses. And now you start to say, give information here using this operator. The England is red. I don't know what is the number, but I know this is the same number. The number of the house, the England, the English person is red, is the same number that the red house. This is the first line. Englishman lies in a red house. The second is the Spanish person have a dog. How to express that in this prologue? Spain house, whatever content, whatever number from 1 to 5, is the same at the house that have the dog. Next one. In the coffee drunk in the greenhouse. Ukrainian drinks tea. Coffee drinks in the greenhouse. Ukrainian house and tea house are the same. The greenhouse, let's go to see the next one. That's the most interesting because now we say from your perspective, the greenhouse is immediately to the right to the ivory house. So, let's say that. It's like if you have the houses from 1 to 5, the house number 1 is the first one, 1, 2, 3, 4, 5. It's easy to say that greenhouse is ivory plus 1. It's just in the right side. And so on. You have all the information we represent in a way that Prolog can understand. And that's all. When you represent all the information that give you in this way, you only have to ask Prolog. Prolog, give me a solution. And Prolog going to give you the solution.
Sorry.
So, yeah.
I have a question. I don't know if it's stupid, but why do we write all the names like England or red as a variable and not as a constant?
Because you have to give the Prolog information. Prolog is very good to find things. You give restrictions. You say that is like you have your constraints or restrictions, your program, and here you represent this problem in a way that Prolog can connect one thing to other things. Say, okay, this is the way that Markus think about this, resolve that. Say, okay, I have a list of houses with these colors. I don't know. I know I have 5 houses in a order that's like one next to the other. A first house and the second, one next to the other. And I know that are things that happen in this house, but I cannot assign a number of the house. I know that there are a red house, another a green, a yellow, blue, but I don't know what is the position of the green house of the.
Okay, yes. Thank
So
you. Yes.
so you have to give the number of the order of the house from 1 to 5.
Yes. Thank you so much. I get it.
This is the reason why you use here variables, and after that, Prolog would find for us what is the number inside this variable, following the restriction we give in this problem. Okay. So I think it's very easy. It's very easy. You only tell you the Spain house, the number is the same at the dog, the same number at the dog house. And here, for example, they create the predicate next to. What means next to? Next to is the previous one or the next one. Is the next to. How would describe that in this way? Is absolute value. That means is the difference of the number of this house and the other house have to be maximum of 1 in absolute value. So if I have, for example, 2 minus 1 are next. The difference is 2 minus 1 is only 1. But if you have 5 minus 1, 5 minus 1 are houses in the middle. So it's not next. It's not the next, but will be next on the right side of the left side. So next, that means the difference here in absolute value is 1. And this is the way to describe the next to relationship with this predicate. It's easy to create for you. I think it's only you have to think in a way to cover this concept of next to numbers, and it's easy to do that. And that's all. You give all the information to Prolog and say, Prolog, give me the solution. Prolog will give you what is the answer. The question is at the end, after all this information, you have a question. You say the question is, who drinks water? What is the name of the person who drinks water? And who owns the zebra? Who is the person? Is the Spanish? Is the, I don't know, is the Ukrainian? Noruego? Who is the person who owns the zebra? And who drinks water? And that is very easy for Prolog to find, because only have to ask, after describe this problem in this way, the solution pair, what is the water and zebra? Prolog say it's the number 5. I don't know. I have to take a look to this way to obtain the solution, but this water is number 1. Probably it's the Norway. And the zebra is number 5. It's the Japanese. Probably the Japanese is the owner of the zebra. I don't know. I have to take a look to the way to represent the solution, but I think that will be that. Is number 3 is England, 4 is Spain, Spanish, Ukraine, Norway, Japanese. So water is number 1. Who drinks water? Drinks water, the Norway. Who owned the zebra? The Japanese. Okay. What do you think? Easy or not? A really complex problem for if you want to resolve that in other programming language that is not Prolog, it's a hard problem to resolve. If you try to resolve that in C++ or Python, it's a hard problem to resolve that, implement a code for resolve that. But in Prolog, it's very easy, like very intuitive way to represent. No? Okay. More questions? Do you agree I'm thinking to publish this video. I think will be interesting for people that are trying to learn Prolog. Do you agree? Because probably this your face will appear in the video. Do you agree to upload this video to YouTube or not? What do you think? Because probably I need your consent to upload the video. If you don't like to your face and your name appear in the video, tell me, and I'm not going to upload the video. What do you think? I need your confirmation to upload. And what you say, that is what I'm going to do.
No problem.
No problem for you, Luca, Alexander,
For me, the same.
Yeah,
Laura.
sure.
Okay, Natalia, Adriana, it's good for you?
No problem.
Okay.
Yeah, it's good.
Elsa, Liva?
Yes, it's fine.
Okay. Natalia, Sawatka? Okay, your face don't appear because you don't have a camera. So, okay, I think that will be interesting for people that are trying to learn. See what your feelings after these 4 months, around 10, 11, or 12 lessons. Okay, some question more. Do you have, John, a specific question for your project or any question? Or if you don't have more,
I have a question.
okay.
Where do we upload the project? Because there's no place in the module. Do we
Yeah.
send
Yeah.
email or?
Yeah, no, I'm going to create a task you can upload. Sorry, I said to you last week, but I didn't create. I'm gonna create before you upload, okay? This is a task to Moodle. You can upload your files. Something more? Nice. Are you happy? Are you happy? You had time to go to the beach or not? This weekend? You went to the beach or not?
I think it depends on the weather. It's going to
Last
be.
week. Okay. Last weekend you went or not?
Oh no, unfortunately I had to learn, but maybe this weekend.
Okay, don't lose the opportunity to go to the Huelvas beach. Very, very beautiful. Okay, nice. If you have more questions in these weeks, you can write me an email. And if you need, I can program an online session to resolve this, if you need to resolve your questions, okay? Okay. Perfect. So thank you so much for your attention, for your time, for your energy these days. I'm so happy this year with this group. I hope you have the seed inside you. Now you have to let this seed grow. Now you have the seed inside you. Probably in the future you can do some tasks in this. For me, it's like magic. After all this time, I'm discovering new things, and now for me it's like more powerful with this constraint, restriction logic, are more powerful, and now I can do more things than before. So I hope you can do some exercise in the future in this way. Okay. So thank you so much for this semester, sharing with you. I don't know, see you, I don't know where, in the bars or wherever. We don't have exam day. Will be nice if we have the opportunity to take a meeting in person if you want. If you want, for me, it will be nice. The day of the exam, if you want to take, to meet, will be perfect. Or if not, we can see in the next online session if you need to resolve your question. Okay. Okay, bye and have a nice week.
Thank you so
Okay,
much.
you're welcome. Bye, you're welcome.
Bye
Bye,
bye.
bye, bye,
Bye.
bye.